All right, so let's get started with today's lecture. Today is day number 8 of the bootcamp, and we have an extremely important topic to cover today. And that topic is using an agent coding framework, which is, I would say, the most popular code-based agent framework at the moment, and that's Langgraph. So we are going to cover several important things today, such as what is Langgraph, how does it differ really from LangChain, why has it become so popular for agents, and then we are going to build projects using Langgraph in Google Colab. I'll try to finish this lecture within 60 to 70 minutes, but like the previous lectures, this is also a deeply involved topic. And if you are planning to implement agents in enterprise or industry, it's highly essential that you master LangGraph. So we are definitely going to code, but I also want to teach you the foundations of LangGraph in a very detailed manner today. So let's begin. Before we start, I just want to give you a quick recap of what we covered in the previous lecture. So in the previous lecture, we started building agentic RAG systems. We started looking at Llama Index, and we saw that what makes Llama Index really special is that it has this Llama Hub, which has many ready-to-use components. It also has document parsing capabilities and an easy workflow system to understand. Then we saw RAG, what is retrieval augmented generation, and we also implemented retrieval augmented generation in Llama Index. We saw that traditional RAG is retrieve once and generate once, and it cannot even use external tools. So if we want to take complex decisions or if we want to plan, traditional RAG does not serve our purpose quite well. So then we discussed that how can we essentially integrate our agentic approach with RAG. And the simple way to do that is pass the query engine as a tool to the agent. And the second important change is that you enter this thought action observation loop, which means that if the answer is not relevant to the query, you go back again and you keep doing this until you're satisfied. This loop is not present in traditional RAG pipelines. That's what makes agentic RAG systems so much more robust. They are better at planning, reasoning. Hallucinations are also reduced because of this thought action observation loop which we have. And the agent has an option whether to use the query engine or not. It can decide that I don't need a query engine and then it doesn't need to use it. So this is agentic RAG, and we also implemented agentic RAG with Llama Index. So I've added all of the steps on this Substack article, creating multiple indexes, building query engines, wrapping query engines as tools, setting up a router query engine, defining the agent, and then finally running the agent. Yesterday, we also saw Phoenix Arise, which is another LLM tracing and evaluation framework. And we explored different colors in this framework and how we can use the colors to understand what's going on. We saw that this cyan blue color essentially is for the retrieved documents. The orange color is for the language model. The blue color outlines the high level steps which the agent is taking, etc. And that's where we ended the last lecture. Today we are going to uh, move ahead with the next agentic framework, and that's Langgraph. So first, I want to mention a quick, essentially distinction between LangChain and Langgraph, and that is where we are going to start today's lecture. And rather than going into definitions, which I already have on the whiteboard, I want to start with an example so that I can explain this difference to all of you in a simple manner. We are going to take the same example as our Spain trip, okay? And let's say I want the workflow as follows. First I want to use Google Flights. First I want to use Google Flights. And I want to find the best flight, which means that I want the price to be less than, let's say, $1,500. That's the first thing which I want. If the price is less than $1,500, what I'll do is I'll move towards booking my hotel. So then I'll move towards the hotel booking. And here also, let's say I want my price to be less than $1,500. if my hotel booking is also finalized, then I'll move to the third step, which is essentially the travel plan. And in this third step, one of my friends has given me this Spain tour guide. And I want to use this Spain tour guide as my reference to make my travel plan. And then that will be the final answer which I want. This travel plan essentially. Okay. These are the sequences of steps which we need to do. Now, if we want to do this sequences of steps using a popular framework which is known as LangChain, what will we do first? We'll first, so can I get some responses from everyone in the call right now? You are to implement this framework using LangChain. Just think about what you have learned about agents so far. How will you implement this? Um, Browser agents. What about others? Can you try to answer this? I know this is a bit of an open-ended question. Tools, browser agent, I can chain multiple steps, etc. So let's say I have three agents. One is my Google Flights agent. One is my Google, or let's say I have only one agent, but I have multiple tools. So I have my agent and it uses the tool number one, which is the search engine for the flights. And remember, LangChain is extremely popular because you can chain different things together. Then after this, you will chain the second tool, which is hotel search. And then after this, you will chain your third tool. And your third tool is essentially the travel plan, the travel planner. And maybe you will also add one more tool here, which is the query engine. So then this directly becomes an agentic RAG because you do have this Spain tour guide over here, right? And we want to refer this document. So then I have a query engine tool over here. So in a way, it's also agentic RAG. But can anyone see the problem over here? So here I'm using LangChain. So I'm creating this sequence, right? I'm chaining one tool to another tool to another tool in a linear manner. What's the main issue with this approach? Remember, the reason LangChain became so popular is because we can chain different things together in a linear fashion, and that's how we can create very complex agentic and even language model systems. Let's see, a failure blocks everything. It's slow. If something fails, if one step fails, the whole trip fails. We want to parallelize, we cannot loop back. But can you try to see what we have not integrated here? Like this flow does not capture some things which I had over here, right? What does it not capture? And I can see some statements in the chat. The thing which it does not capture is something which is called as conditional logic. What conditional logic means is that ideally I should go from my first tool result to the second tool result only if I am able to find a price which is less than $1,500, right? If if this is not satisfied, I will not go to the next step. If it is satisfied, I will go to the next step. Similarly, over here, I have another conditional loop. If the hotel price which I find is not less than $1,500, I I will not go to the next step. So essentially, there are conditional statements here which are very hard to integrate with the LangChain framework. Uh, the only way to do it in the LangChain framework is to wrap these tools in an if-else kind of a block. And that makes writing the code extremely inefficient. So here we have to maintain this linear flow of the tools. And if we were to execute conditional statements, if we are to follow conditional statements, the only way is to wrap every tool call in an if-else statement. So writing the code becomes extremely hard. But now that if-else statements are involved, don't you think there is another way to kind of do this? How do we do if else statements. When you learn about if else statements, don't you have something like a diamond? And then there is a question over here. And then if it goes into this path, you do something like this. If it goes into this path, you do something like this, right? So if there are conditional statements and if the logic which is to be followed is hard, then we should have structures like these. And what do I mean by structures like these? These structures are can be known as graphs. You might think of decision trees. It can also be called as a type of graph, right? That's where actually Langgraph comes into picture. Now let me give you all another way to represent this same thing, and then you tell me what you think of this. Okay, the way I'm going to now, instead of doing this linear kind of approach, what I'll do is that first I'll have my flight booking node. I'll explain what nodes are. I'll have my flight booking node, and this will have a tool. This will have the search tool. Okay. I will keep on going in this loop. So I'll make a loop over here, and I'll keep on going in this loop until I have a flight which is less than $1,500. Okay. So if I get a flight which is less than $1,500, then I will move to the next step. If not, so for example, if I don't get a flight, I will end it over here. But if I go through these multiple steps over here and I do get a flight which is less than $1,500, I'll go to the next step. In the next step, what I have is I have my hotel booking. So even here, what I'll do is that I'll have a search tool, and I'll go into this loop again. I'll go into this loop again over here. I'll go into this loop as many times as I can. If I find a hotel which is less than $1,500 is great, but if not, I'll end it over here. But if I do find it, I'll go forward to the next step. And here is where I have my travel plan. The tool which I have over here is my query engine tool. So this is where the agentic RAG comes into picture. This is where I have my query engine tool. And I will keep on querying this until I get good results. If I get good results, I will return my results over here. If not, I am going to end it over here. So now take a look at the structure which is assembled over here. On the left hand side of the screen, we have this structure, right? And if you compare this structure with what was there on the right hand side of the screen, there is a fundamental difference. The structure on the left hand side is a graph based structure. So this is a graph based structure, and the structure on the right hand side is a linear structure. The advantages of graphs is that why people love dealing with graphs is because it allows you to deal with complex systems in a much better manner. You can you can incorporate as much amount of complexity as you want. You just increase the number of nodes, you increase the depth of the graph to make it more complex. Then you have multiple thought action observation loops over here. If you think about it, this is a thought action observation loop. This is a thought action observation loop. This is a thought action observation loop. So I have three thought action observation loops integrated within this graph based interface right now. Whereas here in this kind of a linear approach, it really gets very difficult to deal with complex decision making. And when people started making agents, if and else statements are bound to come, right? Because that's how we plan. Think about how humans plan. If I have the money, I will do this. If I don't have the money, I will do that. So it's like if else statements govern our everyday decision making at every step of the way. So LangGraph actually came later than LangChain. Initially, people were building agents using LangChain. But even LangChain's founder now advocates using LangGraph for building agents. Because as you can see here, LangGraph enables us to design agents that can reliably handle complex tasks. And one major reason for this is that conditional, we can make it very easy to deal with conditioning using a graphical structure instead of a linear structure. You can have conditions even in a linear structure, but the code gets messy very quickly. And as a developer, it becomes very difficult to then visualize the code to debug errors, etc. But if you have a graph-based system, things actually become very easy. Then the another advantage of graph-based systems is something which is called as state persistence. What state persistence actually means is that the state which was X, and we'll learn about what state means in a formal manner. But for now, just think about it this way. What all information was accessible at the top of the graph, that's percolated down. Since it's a tree-based structure, the information of the top at the top is easily percolated right till the bottom. So the state which is available at the top of the graph is easily available at the bottom of the graph. That's called state persistence. So it's very easy to deal. Usually you don't want state variables to become lost when you define complex decision-making workflows. In chain-based structures, it's easy for the state variables to get lost. But in a graphical based structure, it's easier to retain state variables, or rather, it's easier to maintain state persistence. That's a deeper level advantage of graph or Lang graph rather compared to Lang chain. So now, instead of diving into definitions, I wanted to first explain all of this to you with a practical example so that when all of us now look at the formal definitions, you have something in your mind to visualize, right? So I could have directly started with this, but this text does not make sense unless you have some kind of a example. So whenever I'm explaining this text to you right now, always think back to the example which we have just seen. So as I told you, Langgraph is a specialized library within the LangChain ecosystem. LangChain ecosystem developed first, it matured first, and Langgraph came a bit later. So LangChain is ideal for building LLM applications where things are kind of chained together. So you retrieve the data, then you split the text, then you summarize the text, then you generate the response, right? This is a linear operation. This is a simple linear operation, and LangChain is good to do these linear operations which are chained together. But LangGraph, the advantage of LangGraph is that it can handle non-linear processes quite easily. And what do I mean by non-linear processes? Non-linear processes look like this. You check something whether it's yes or no. Let's say if it's no, you complete the task. If it's yes, you add the task, and finally you summarize the task. So now see, what I see on the left hand side is a complex workflow which involves decision making at several different points. It involves making a decision here, then going into one of these flows, then doing these tasks, and then merging the results of both of these tasks. This is a non-linear process. Nothing flows in a sequential manner over here. And not just that, after you summarize the tasks, you have to feed it back, let's say, to the input. If your process looks like this, then it's much more advantageous to build a Lang graph because you can easily visualize it like this. Another example is that, let's say, we want to um, have a document, right? And we want to decide whether we want to directly use a code agent for the document, or we want to just use LLM on text or OCR plus LLM. So what you can do is that if the user question and input document is the overall input, you check the document type. If the document type is an Excel sheet, you can simply use a code agent with pandas as the tool. But if it's PDF or text, you can check for images or tables. If images or tables exist, you can use OCR. If images or tables also do not exist, you can directly use LLMs on the text. If you are not familiar with some of these terminologies, don't get confused. But here I've just highlighted two use cases of what a complicated scenario might look like for decision making. And finally, this one schematic explains why you would want to use LangGraph over LangChain. So LangChain focuses on sequential LLM operations and LangGraph handles non-linear workflows. That's one major reason. Second thing is LangChain includes memory, prompts, etc. But LangGraph has nodes, edges, and states. So I like to remember this as N, E, and S. We are going to learn about what nodes are, what edges are, what states are very shortly. but the entire framework itself is different. The whole agent is orchestrated using nodes, edges, and states. Then, as I mentioned to you before, LangChain has limited state persistence, if you see, but Langgraph offers robust, accessible state management. All right, so I hope now you have got an overall picture of, okay, what is Langgraph, what is LangChain. Although some things will still be unclear to you that, okay, what are nodes, what are edges, what are states. I have not explained this NES framework to you, but I'll do that shortly. Until this point in the lecture, if anyone asks you, why would you use LangChain over LangGraph, you should be able to answer at least qualitatively as of now. We'll make it quantitative as we go through the code in more detail. Now, let's come to how does LangGraph really work? And I'm going to first quickly explain to you the definition, and then we are directly going to go into an example which we are going to code out. Usually all LangGraph tutorials directly start with code, but I don't think that's the best practice because unless you understand these foundations, it will be difficult to understand the code. So to understand how LangGraph works, we need to first understand its building blocks, which is N for nodes, E for edges, and S for states. So we'll start with the state first. It's user defined and maintained and passed between the nodes. Nodes essentially are functions and edges connect different nodes to each other. I know this is a bit fast, but essentially, if I were to go to this same graph which I just showed you, these ones are nodes. So the flight booking, these ones are nodes. The nodes are connected together by these lines which you see over here, right? These lines are the edges. And the state is essentially what you're maintaining throughout. So for example, if we are tracking the price over here, price can be the one state variable. If we are ultimately tracking the destinations where we want to go to, that can be another state variable, etc. So state is user defined and maintained, such as price, travel locations, etc. Nodes are functions which call a tool. So if we are using if it's a travel node, it uses the query engine tool. That's a node. If it's a flight booking node, then it uses the search engine tool, etc. So nodes are essentially functions, and nodes are functions of the state variable. And edges essentially connect different nodes to each other. So if you see this right now, the framework can look something like this. You start, you have node number one, you have node number two, and you have node number three. Each node can have access to certain tools. And then you specify the connection between nodes as edges. So this is edge number one, this is edge number two, this is edge number three, and this is edge number four. This is a simple graph using the NES structure of line graph, which is nodes, edges, and states. Now, let us understand this in more detail by taking a simple example. What we are going to do is that today's first example is email sorter and sender. Email sorter and sender. So the example is as follows. We are going to uh, receive an input. We are going to receive an email as an input. Our task would be to first determine whether this email is spam or not a spam. That's why it's email sorter plus sender. If it's spam, then we don't do anything. We just end it over here. But if it's not a spam, we draft an email. We draft an email and we send it to the person. So you can think of this whole framework as an assistant screening emails for their manager, essentially. So you can think of this as assistant screening emails. So the assistant will get the input email. They'll determine if it's spam or not spam. If it's spam, they'll not do anything. So we'll just end. But if it's not a spam, they'll draft an email and share it to the manager saying that you have received such and such email from this person. So this assistant filters spam and not spam and directs the not a spam to um, the main person. Okay. So now what we have to do is that we have to make a land graph framework out of this. So this is an agent which does all of these things. We have to make an agent who does this entire workflow automatically, and we have to make this agent using Langgraph. So based on whatever you have understood so far, it's fine whether the answer is correct or not. What do you think the state of this agent should be? What should be the state? You know the problem statement which I've just mentioned, and you vaguely know the definition of the state, edges, and the nodes. Um, what do you think should be the state in this agent which I've just defined on the screen? Email content, sender, original email, email. Okay, great, right? So all of you are getting the basic idea of what the state should be, and I've just written it over here. So the state of this agent is essentially going to be the email. So this is a dictionary which contains several different things and which we are going to track throughout this building process. We have the email content, the input email content itself. Then we also have whether the email is spam or not a spam. Why do we have this as a state variable? Because that will be passed for our future decisions. Then what else do we have? We have email sending draft as well. So if the email is not a spam, we have to make a draft. So we have this draft over here, and we have the spam reason also in case uh, we want to send this information to someone that, okay, why is this email spam or why is it not a spam? We have the reason if we have classified it as spam. So these are the variables which will be propagated throughout our graph. When I say propagated, I mean that all the actions which we'll have to do later, such as we have to detect whether spam or not spam, right? That's why we need this state. We have to detect or we have to draft an email to the manager. That's why we need an email sending draft. And if the manager asks for a reason that why is this email classified as spam, if we maintain that in the state, it's good. And of course, we have the email content also in the state. So this is the state out of the N, E, and S framework. Now, can you tell me what should be the nodes? And remember, the simplest way to think about nodes is just functions. Nodes are just functions of the state variables. The fancy way of calling them is nodes, but they are essentially just functions. So in this problem statement which we have, what should be the nodes? And again, this is a bit open-ended question, but try to think to the best of your abilities. We can see some answers such as read the email classifier, spam identification. Correct. All of you are getting into the or going in the correct direction. The nodes, I'll have 5 nodes. My first node is I'm going to just read the email essentially, which means take in the content of the email, because the email can have several things, right? It can have the sender information, the sender email ID. I just need to take the body or the content of the email and read it first. That's the first function which I need to define. The second is classify the email. So I'll need to classify the email between spam and not spam. And I think all of you have mentioned this. Third is handle the spam. What does handle the spam mean? It means that if it's not a spam, we have to end. We don't have to do anything. Sorry, if it is a spam, then we have to end. We don't have to do anything. But if it is not a spam, then we have to use this node, which is draft an email. And then finally, we have to notify the person that, okay, this you have received this email, and we have to send that email to that person. These are the 5 nodes or the 5 functions. And so node, states, and edges. Edges will essentially connect the different nodes to each other. So if you see this right now, this is how we are going to assemble the states, and this is how we are going to assemble the nodes. So if you see whatever is marked in purple color here right now, those are the nodes, right? So read email is one node, classify email is the second node. These are the 5 nodes which we see, 1, 2, 3, 4, 5. Those are marked in purple color. Read email, number 1, classify email, handle spam, drafting response, and notify whatever the manager name is. Okay, these are the nodes. And now in this step, we have to determine the edges. This is an important step because it's crucial to understand what's the workflow we are following. The first, when we start, we are going to read the email, right? So that's going to be our edge number 1. After we read the email, we are going to classify the email, whether it's spam or whether it's not a spam. So that's the second. Remember, nodes are functions and edges are connecting the different nodes to each other. So this is my edge number two. Now here is where I have an edge which is called as conditional edge. These edges which are over here, these are called as direct edge. This is called a direct edge because there is no conditioning which is happening here. Edge number one and edge number two are direct edges. But after we classify the email, we have a conditional edge because if it's a spam, we have to handle the spam, which essentially means we just end. So this one, edge number three is a conditional edge. Edge number four is also a conditional edge because if it is not a spam, then we have to draft a response. Uh, so then we have edge number five, and then we have to notify the manager, and then we have to end. So that's edge number seven. So there are seven edges in this graph. Edge number one, two, uh, 1, 2, 5, 6, and 7. These are direct edges, and edge number 3 and edge number 4 are conditional edges. This is the power of Langgraph, right? You can very easily define a direct edge, and with that same ease, you can define a conditional edge as well. In this one figure, now you should understand the difference between nodes, states, and edges. State is nowhere shown in this figure, right? Because states are our variables. They won't be shown in this figure. State is the body of your email, whether it's spam or not, your draft email itself. Those are the state variables. What will be shown in this figure is essentially nodes, which are functions. And you will understand it better when we define these nodes in Google Colab, but essentially these are functions, right? And functions are connected to each other through edges. That's why the framework is called nodes, edges, and states. And when nodes, edges, and states are assembled together, so if you zoom out and see now, this is state, these are nodes, and these are edges. When the nodes, edges, and states are assembled together, it leads to something which is called as a state graph. So this is the container which holds together the entire agentic workflow, something like this. In Python, you can visualize the state graph, and the important thing is you can invoke the state graph. Invoking a graph essentially means starting through this entire workflow and reaching till the end. That means invoking the graph. And it's very easy to define the invoke statement. You just have to do graph.invoke, and then we'll start the entire sequence from node 1 to node 2 to node 3, etc. So that is the whole idea. And more formally now, state is a central concept. It represents all the information which flows through our graph application. Nodes are essentially Python functions. They take state as an input, they perform some operation, and they return updates to the state. Edges connect nodes and define possible paths through your graph. And edges can be direct or edges can be conditional. Direct edge always goes from one node to another node. A conditional edge can choose the next node based on the current state. And then finally, we have the state graph, which is a container which holds the entire workflow, and we can invoke a state graph. So in the previous frameworks, you remember we did agent.run. An equivalent of this in Langgraph, or when we are assembling a graph, is essentially graph.invoke, which invokes the entire graph. Now here, if you see very closely, I have not told you where tools are used exactly. And we are going to look at that in our second demonstration of today. The first demonstration is building this email sorter and sender. In the second demonstration, I'm going to show you how you can augment such a graph with tools. But if I directly show you tools, then it becomes a bit more complex. So let's start executing this first example now on Google Colab. So what I'm going to do now is that I'm going to share this Google Colab code file with you. Let me start sharing my screen. First, I'll open the code file on my drive, and then I'll be able to start sharing the file. So I want to share two Google Colab code files with you today, but first let's just start with one so that it will be easier. Yeah. So I've just shared the code file. All of you can take a look at it. Meanwhile, let me answer some questions in the chat. Where is the thought action observation loop here? That's a very good question. So in the first example, we don't have the thought action observation loop. We are going to see that in the second example when I'm going to show you how tools are used. In the first example, we are going to very simply assemble the functions, but we won't show the TAO loop. I'll show the TAO loop in the second example. You can call this as an email processing agent, a simple email processing agent. Does this not add a lot of time? So it actually for complex workflows, it's much faster because in LangChain also you have to do if else statements if you want to do these workflows. It just flows much faster in complex workflows. For simple workflows, even LangChain can be used, but in complex decision making, LangGraph, it's actually shown to have better performance and also more efficient with respect to the code. So before now all of you start running the code, you should have the OpenAI API key. So just copy paste the OpenAI API key over here, os.environment OpenAI API key. And the second thing which all of you will need when you scroll down below is that you will need access or you will need your API keys which we used in LangFuse. So LangFuse, if you remember, was the workflow which we covered in I think lecture 3 and lecture 4. Here is where we are going to observe our LangGraph agent. So if you have your public key and secret key from LangFuse, you just have to paste it over here. How many of you have these keys from LangFuse, which we had covered in one of the previous lectures? All of you should be having these keys because if you have these keys, you should very easily see the observability now. Setting this up for the first time, it takes time, but once you have the keys, you can directly use them here. So let's get started with the examples. In this notebook, we are going to set up this LangGraph workflow. I would call this a very simple agent with minimum agency. A full agentic workflow will be our second code, which we are going to cover today. But in this notebook, I want you to get familiar with states. I want you to get familiar with nodes, conditional branching, and essentially how to run the entire graph. Only then we will be equipped to understand agents. Because LangGraph is slightly more complex because of this graph-based approach. But once you understand how to make this graph, it will be very easy for you to assemble agents. So first what we have to do simply is that we have to install packages. So here I am installing LangGraph, LangChain OpenAI, and LangChain Hugging Face. You can install 3 packages. And while this is being installed, let me explain to you what we are going to do step by step below. So someone is asking for the Google Colab link, right? Let me share it to you once more. Yeah, so this is the Google Colab link. So these packages install pretty fast because LangGraph is very lightweight. As you can see over here, it does not take up too much space. Then what we can do is that we can import the OpenAI API key. And as I mentioned, our step number one is always to define our state. So pay very careful attention to the steps which we are following right now. The first step is to always define our state variables. And before even going to the nodes, before even going to the edges, nothing will function forward if you don't define the state. And as we have seen, the state, so we are going to create a class called email state, and every instance of this class will essentially be a dictionary. And what will be the elements of this dictionary? We have already seen this. It will contain all of these. It will contain the email content, spam, not spam, email sending draft, spam reason, etc. So you will see that this has now 5 things. The email content, whether it's a spam, spam reason, email category, email draft, and messages. This message is very important because this is kind of like our conversation history, which is stored. So as you are going through the entire graph, it's generally a good idea for you to store messages. It's like caching memory because your answers might improve if you have memory. So this you can think of as caching or having the memory. So this is the state. That's it. We have defined the state, and then we have to define our nodes. Remember the definition of nodes. Nodes are essentially just functions. So don't need to be confused by nodes. These are just functions, right? So as you can see, each node here is a function. It's a Python function. So the first email is read email. And what we are going to do, we are going to access our state and we are going to access this key called email. That will give us our email body. And then we are going to print out an AI agent is processing an email from the sender with this subject. So just to give you a sense of what the email will look, the input will look something like this. It will have a sender, it will have a subject, and it will have the body. So this body part is what we are actually storing as the content of the email. Um, so an AI agent is processing an email from email sender with subject as email subject. That's the first step, which is read email. That's our first node which we have defined. Moving forward, the second node is classifying the email. Can someone tell me how do you think we should classify this email? What will we write? How do we do this classification task? So I can see LLM, right? There are multiple ways to do this task. We can use a classification model. We can use a decision tree. We can use a language model. Anything is fine actually, but for the sake of simplicity, what we are going to do here we are going to use a language model. And that's why we have defined the OpenAI API key. This is again why I always mention that the transformer architecture revolutionized everything because a language model can now see my email and understand whether it's spam or not. If these were not involved, I would probably need to use a classification model or a decision tree, etc., or any other traditional ML techniques. But as I've seen here, as a professional email reader, analyze this email and determine if it is spam or legitimate and should be brought to the person's attention. And then I actually give the email. So as I showed you, our email has a sender, it has a subject, and it has the body. So the LLM has access to our email. And we have mentioned first determine if this email is spam, answer with spam or ham if it's legitimate, and then only return the answer. And then what do we have is that it is if it is not a spam, then we update our messages with the prompt to the LLM and the output of our LLM. If it is a spam, then we just store the is spam state essentially. So here in this function, which is classifying the email, what we are doing is that we take the message which is received from the human or the input message. We are going to do model.invoke messages, which means our LLM will run on this on this input message, and then it will answer whether it's spam or whether it's not a spam. And then we'll print the response text. The LLM would respond something that it's not a spam because etc etc etc. If it is not a spam, we are going to update our history. If it is a spam, we won't update our history. And then we are also going to update this is spam state. So remember here we have this is spam, right? We are going to update this based on whatever is the result of the language model. And then we are going to update the history also with new messages. So this function is actually doing three things. This is not only classifying whether the email is spam or not, but it's also updating the is spam variable in the state, and it's updating the history. So if you now scroll back here to our figure, what we are doing is that first we are reading the email, and then we are classifying the email. And after classification, our state, now as you can see, our state gets modified. So state gets modified as we flow through the graph. State gets modified as we flow through the graph. So here, after this function, the state is modified. keys of the state are modified, whether it's spam or not a spam, the history gets modified, etc. And then we can do the further actions. So the next step is that this is the second node. The third node for us is handle spam. So if it's spam, we don't have to do anything. We just have to print that the email has been moved to the spam folder. But if it's not a spam, then we have to connect an edge to this drafting response, right? This drafting response. So what the drafting response node actually does is that it gets the email body, and then we say that as an AI agent, draft a polite preliminary response to this email, draft a brief professional response that the person can review and personalize before sending. So this is like the assistant is drafting an email to the manager saying that you have received this email from this person, and not just that, they're creating a first draft of the response, and then the manager can just quickly edit and submit. So here again the same thing, human message, the content will be the prompt, and then the response is added, and the response is added to the history. So again the messages of the state are updated, and one more variable of the state is now updated, which is the email draft. The email draft is updated and the messages is updated. So after this, so messages are updated even here and here because the history is updated every single time. But after this drafting response, that particular variable is updated. So if you scroll up and see the state, this email draft variable is now updated with our draft response. So this is the drafting response function. And now I think we have written all the functions which are necessary except for this last function, which is notifying the manager. Here we have to say that, hello, I am your agent. You have received an email from this. I have prepared a draft for your review, and then the email draft. So this is the final email sent to the manager saying that I am your AI agent. You have received an email from the sender. I have already screened that. So we can write here, I have already screened that it's not a spam. And then I prepared a draft response for your review. That's it. And then one more thing which is there is the routing logic. So routing logic, essentially what it does is that we will need the routing logic at the place where the conditional edge is there. So we have conditional edge number 3 and edge number 4, right? So the routing logic is that you check the state and especially check the is spam. If it's spam, then you return spam, otherwise you return legitimate. So if it's legitimate, we'll actually call this drafting response. But if it's spam, then we'll actually do handle spam and end. So this is where we write the routing logic. This is how conditional statements are handled in graphs, right? And then you define a state graph and you add all the nodes. Here we have added 5 nodes: read email, classify email, handle spam, drafting response, and notify Mr. Wayne. So notify the manager. These 5 nodes have been added to the graph right now. But remember, we have not created edges until now. Until now, we have only created nodes, which are the functions. And if you see, every function is doing a couple of different things. So if you now just take a look at the functions or the nodes over here, it's not just simply doing this task. So for example, this read email is the simplest of all functions because it's actually just only reading the email. But classifying the email is updating the state and it's updating the history. Handle spam is also simple node, but draft email is not very simple. Draft email is updating the state and it's also updating the history. And notify person is also simple. It's just sending the email to the person that I have prepared this draft for you, etc. So state needs to be updated. If state is not updated, then this routing also will not take place because only when the state is updated, we know whether the email is spam or whether it's not a spam. Now, the final thing for us to do after defining the nodes is actually a very easy thing, and it's one of the main advantages of Langgraph, I think, because it's very easy for us to define our edges now. It's just very visual, right? Once you have created this visual workflow, you know there has to be an edge between the start and the read email. So that's what you write here. You create an edge, you add an edge between start and read email. Then you add an edge between read email and classify email, which is this edge, and then you create a conditional edge. So direct edges is just adding a add edge, but to add a conditional edge, the statement is add conditional edges. And then you add conditional edges, which is conditional edge from classify email. And it will first use the route email function. And remember, route email returns whether spam or legitimate. So if it's spam, then we actually go to handle spam. If it's legitimate, we go to drafting response. So it's these edges which are now created. And then finally, we add an edge between handle spam and end, which is this edge. We add an edge between drafting response and notify Mr. Wayne, that's this edge. And the last edge is adding the edge between notify Mr. Wayne and end. It's this edge. So that's how we have added every single edge over here. But you see how visually intuitive it was to add these edges. Otherwise, if we are using lang chain, we'll have to write if else statements. We'll have to write if else statements. It would have become very difficult for us to keep track of every single thing. But once you visualize the lang graph, it's just these look like just English statements, right? You just have to keep in mind add edge and you have to keep in mind add conditional edges. That's it. So you can run this now. Email graph is not defined. Okay, I don't think I ran the previous node. So you can run step number 2. Step number 3 is defining our routing logic. Actually, here we have defined the routing logic and add edges. And then finally in step number 4 is where we create the state graph. So in step number 4, what you do is that you have this email graph and you just do email graph.compile. And one cool thing about Langgraph is that you can actually visualize your graph here in code. So if you run this code cell, you will visualize this entire graph like how we are seeing it on the Miro board. So whatever you're seeing on the Miro board, Python has exactly parsed it into the same thing: start, read email, classify email, handle spam on one conditional site, drafting response, notify Mr. Wayne, and then end. That's it. Our graph is now compiled. As the last step, what we need to do is just take our input, um, is to give input emails for testing. So we create two types of emails. We create one legitimate email. So what I've done is that, let's say Cognizant AI potential partnership. We would like to explore a potential partnership collaboration with Visuara. Do let us know a good time to reach you. This is a good email, right? This is a legitimate email. But here it's crypto bro, the best investment of 2025. This is definitely looks like a spam. So I'm going to test these two emails. The way to test this is just once we have done the compiled graph, right? We have compiled graph. We just do compiled graph dot invoke. So we invoke the graph for this legitimate email and we invoke the graph second time for the spam email. And when you invoke, you have to pass the state variables. So initially when we define the state, it's only the email which we have, right? None of these other categories are filled. This will be filled when one particular node will be called. This will be filled when one particular node will be called, etc. Initially, when we pass the input, we have no information about these other state variables. So these are my inputs right now, and I have defined two emails and I've invoked the graphs. So let's see the result right now. So processing a legitimate email. An AI agent is processing an email from Cognizant AI with the subject potential partnership. The agent has decided this is ham, which means it's not a spam. And then, hello, I'm your AI agent. You have received an email from Cognizant AI. It's like I am receiving this email now from my agent. I have already screened that it's not a spam and I have prepared a potential draft response for your review. Thank you for reaching out to us at Vijwara. We are excited about a possibility of collaborating with Cognizant AI. Could you please suggest a few convenient times? That's great, right? So now my time has been reduced. I can directly take this email. I can edit out a few things and I can send it. But the second email is this. For the second email, AI agent is processing an email from Crypto Bro with this subject. Alfred or has marked, or I should write here, AI agent has marked this email as spam. The email has been moved to the spam folder. So see, when the email is actually spam, we don't do anything with it, right? We just do handle spam, which is the text that the email has been moved to the spam folder. And then we return it. So when I teach you in the next code how to use tools, you can simply add the Gmail tool over here and put it in the spam folder of Gmail. So it's as simple as that. But I hope now all of you have understood the workflow of the NES, nodes, edges, and state. How many of you have reached until this part of the code? Can you let me know on chat whether this is working for you as intended? So for me, it gave the correct responses, but I want to see. Okay, I have. Okay, good. So for all of us, the responses seem to be correct. This is an example of an all the Langgraph agents look like this. Whether you are assembling a simple agent or whether you are assembling a complex agent, at the heart of it, they have the node, edges, and state framework. You have to very carefully define though what every node does, how it has to update the state, and you have to carefully define the conditional edges, and so that it handles the conditional logic correctly. Now, as you can see here, we have not really added tools in this particular example, but I am going to show that in the next example. Before going to the next example, as always, we have to inspect using Langfuse. Now, I am doing this in every lecture because I want to drive home the point of evaluation, right? And I will keep on iterating this because I think this does not receive too much attention really. Because when you work on industrial projects, this is the most important thing a client really cares about. They don't care which framework you have used, etc. They want to care about whether the agent is performing well on their data, on the test data or not. And for that, if you don't understand evaluation observability, in fact, it will be very difficult. So for example, today we are going to again set up an observability framework through Langfuse. Now we have done it so many times that after this, all of you should have mastered this. So there is a question in the chat about Langsmith, right? Langsmith is also very popular. Um, and once you understand Langfuse and Langfuse and Arise Phoenix, all other frameworks look exactly the same. So if you see yesterday what we saw with Phoenix looks exactly same as this, right? These are all competing products at this point. As long as you know how to use one or two products very well, it's good. So here again we are doing Langfuse so that you can practice more. So here you can install Langfuse, and as you scroll down below, you will see that here is the point where you have to enter your public key and your secret key. Now, I am not going to show how to get these keys again because I have already shown this before, but just for a very quick demo, you can go to Langfuse and whatever project you have, you can go to project and you can go to settings, then you can go to API key. And here what you can do is that you can generate a new API, create a new API key, and here you will get your secret key and you will get your private key. Then what you can do is that run this. This is the public key and this is the secret key. And here what we are doing is that we add a Langfuse callback handler. So once you have the callback handler, you call the same thing. So if you see legitimate result, we did compiled graph.invoke earlier also, right? So everything remains the same. The only difference is that we add this config. We add this config over here, which is a callback to the Langfuse handler. That's the only thing which changes. So here we indicate Langgraph that we are connecting this with Langfuse. So you can run this right now. Let me see on my dashboard whether I am able to actually see the traces on Langfuse or not. So I'm just going to go to my Langfuse portal right now. And I'm going to share my screen. Okay, so see here the time is 3 p.m. over here, 46 seconds, and I have seen and 3 p.m. and 43 seconds. Why do I see two traces over here? The reason I see two traces over here is because I'm running two input examples, right? So if you see the first input here, you can exactly see what framework our agent followed. We started read email, classify email, then it was not a spam. So it drafted a response, notify Mr. Wayne and end. That's the framework which we followed. And here you can see that it was classified as not a spam, and then the email was also drafted and sent to the manager for review. But if you see the second email now, let's see. If you see the second email now, that's the spam email. So if you see the graph for this is very different, right? And here you can actually move around this graph. So I'm moving this right now. Here you can see that start, read email, classify email, handle spam, and end. This graph is very different than the second graph which we saw, which was for not a spam. So here it was classified as not a spam. But this is the advantage of using an observation platform. Because now if I'm explaining it to a client, rather than showing it through a Google Colab notebook, it's much easier to show it over here. Because here if you see the response is aggregated in a much better manner. Um, okay, so this is Langfuse, and now we have seen it multiple times before. So those of you who are not able to see this trace, you might just need, you must not have configured your API keys correctly. So just check that once after this lecture is over. Now what we have to do is that we have to move to the next part of today's lecture, where we are going to equip our agent with tools. Um, so let's see, there is a question, does order of adding nodes edges matter at all, or just the correct edges? No, order matters a lot, because if the ordering of the nodes and edges is not correct, the agent can get completely confused. And it's upon the user to make sure that the order is correct. I'll show you that in the next example. We are now going to define the tools in a very smart manner. And there, if the order is not correct, then the agent, as you have mentioned, might go into a loop. And cyclic graphs are fine, right? We are going to design a cyclic graph right now. I'll show you how to design a cyclic graph. So if you are to enter a thought action observation framework, by default, you have to mention cyclicity somewhere. The only question was that how to integrate this thought action observation loop into our state edges and nodes right now. So currently I showed you these nodes, right? That's fine. But how do I integrate a thought action observation loop over here? That's what we are going to see in the next code. Why are we seeing the traces? What is the use judge as LLM? Okay, so this I explained in the previous lecture also, right? Evaluation has two components. Without observing something, it's impossible to evaluate something. So observation is one thing and evaluation is the second thing. And in one of the previous lectures, I've also showed you how to set up evaluation dashboards on Langfuse. So once we observe, what we can do is that we can go to Langfuse and we can go to evaluation and we can set up an evaluation dashboard. I've shown you how to do this. You have to create an evaluator. You have to first set a default model. Here you will need an API key to set up the default model. But once you set up the default model, you can select the relevant evaluation metric which you want out of these. And then you can hook it up with your output, with your agent output. But there are two sides to this. Evaluation does not make any sense without observation. And typically observation is far more cheaper than evaluation. So you definitely need to have observation set up first. All right, now let me ask you this question that, let's say, so this is the first example, right? The second example which we are going to build is that we are going to build a vision assistant agent. We are going to build a vision assistant agent using Langgraph. So basically what the vision assistant agent will do is that it will look at an image and then it will print out what's present in that image. So the task itself is pretty simple, but the way we are going to set this up is using a slightly different mechanism. So first, let me ask you, what will be the state over here? In this example, in the second example, which we are going to see, now you have understood about state, node and edges, right? What will be the state in the second example? Image, correct. So all of you who have got this answer are correct. So the state is the image. What about the nodes? What will you need as functions? I can see some answers such as load image, classify image, scan image, image classification, etc. So um, for nodes, what we can do is that we can just simply have an LLM like what we did before. But that's not a good thing because in the code which we have seen right now, we did not have a thought, we did not have a loop. I want to now integrate my tool. So we are going to use an LLM itself. My question to you is that how can we integrate a loop? Which means I don't want to run the LLM once and stop. I want to run the LLM in a loop until I get to the right answer, like the thought action observation framework. How do we do this in a graph kind of a structure? Loop counter via edges prompt. So the way Langgraph actually does this is very, very smart. And I've seen this pattern enough times for anyone who is defining agents with Langgraph. The way they do it is that they actually define two nodes. They define a tools node and an assistant node. So the way this happens is that there is an assistant node. The assistant node essentially is connected with my tools node. And the other node is connected to the end. So the cool thing about this is that the assistant node and the tools node are connected in a loop. And this is where that thought action observation framework is executed because the what we can instruct is that the assistant node keeps on calling the tools node until a certain condition is satisfied. If it is satisfied, we can go to the end. So that's how we can exit it and we can prevent this from becoming an infinite loop. But if you see, if you just have a tools node, let's say you just have a tools and you have an end. There is no way to make this into a loop, right? So what people figured out is that you just have another node which is an assistant node. So if you think about it, the assistant node is nothing special, but the assistant node can make calls to the tools node if it thinks it's necessary. So the assistant node gets the output from the tools node, that's the observation. Based on the observation, if it realizes that it needs to call the tools again, it goes into this loop again and again and again until it's satisfied. And in this tools node, essentially, you can add all the tools which you want. The query engine tool can be added here itself. The archive tool, which we saw last time, can be added here itself. The web search tool can be added here itself. So all the tools can be added over here. And by defining this kind of a loop graph structure, we are simulating the thought action observation framework, which we learnt about in the React definition. And the assistant node is not really an LLM. The assistant node has access to an LLM. So it can make use of the LLM to decide whether the answer is correct or not, or whether it needs to enter into a loop or not. So you can think of the assistant node having access to an LLM. The assistant node is not just an LLM. It needs to have access to an LLM, and this is a conditional. So this is a conditional edge over here, which means we can decide where to go, either to go here or to go here. We don't know. That depends on what the assistant node decides. If the assistant node decides that we don't need the, I don't need the tools anymore, then it can end it. So if the assistant node gets an answer, it can end it. But if the assistant node thinks that I need a query engine tool, that's good. Then it again thinks that I need the archive tool, then it goes back here. It again thinks that I need the web search tool. So we can keep on going in this loop until the assistant node is essentially satisfied. So that's how the agentic kind of a thought action observation loop is integrated within LangGraph. And here again, the graph based structure helps a lot because the thought action observation is a loop, right? And through this kind of, you can simulate a similar loop over here by a bidirectional graph. So this is nothing but a bidirectional graph between two nodes, and that simulates the thought action observation loop. That's one link between Lang graph and the React uh, thought process which we have seen. And any kind of agent which you see using LangGraph, all types of complex agent, if you want that agent to have access to tools, the way you can do this is to set up the assistant node and make it go in a loop with the tools node. And now we are going to see a code for this. So let me let me share that with you. Okay, so before sharing the code, I just want to make sure if there are any API keys which have been exposed. So I'm just removing those and then I'll share the copy. Yeah, so now I'm sharing the code in the chat. This is the code file. You can try to open this right now. Actually, along with this code file, you will also need one more image, which I'm sharing now on the chat. So I've shared one image on the chat. It's essentially an image related to Batman. You can use any image which you want. You can download this image. We'll need it at a particular point in the code. I'll tell you when. So again, I'm sharing my screen right now. Okay, so I have actually divided this into part one and part two. I don't think we'll have time to go through part two today, but I'll share that code with you. I'll explain what part two is later. So first, let's do the same thing. We'll have to install Langgraph. We'll have to install Langfuse. Um, let me, and then you will need API keys. So for example, yeah, you will need OpenAI API key. You'll need Langfuse public key. You'll need Langfuse secret key if you are connected to Langfuse. And then you run this. And on the left hand side, you will need to upload the image which I've shared on the chat. After this lecture is over, you can replace the image with any image which you want. But here I have named it as Batman training and meals.png. So just add any image which you want over there. And again, these are the same Langfuse credentials which you are using. So you don't need to change this because for the entire duration of the bootcamp, it's fine if you see all the traces in one place. Later, it will be useful for you when you revise this entire content. So now I've installed all of this. The next step is again the same Langfuse handler. And this is where we are going to define the tools. So remember the first tool which we are going to use is the vision. We need to extract text from the image, right? So that's going to be one tool. And I'm going to define the tool as extract text. And remember, this is just a simple language model which can understand what is present in the image. So I'm going to define a vision LLM, which is OpenAI GPT-4o, which can essentially take images as the input. And what I've written in this function is that it just extracts text from an image file. That's it. So I've given a prompt that extract all text from this image, return only the extracted text, no explanation. That's it. So this is the first tool which I have, which is extract text tool. And the second tool which I've randomly added is a divide tool, which divides two integers. So here the reason I've added this random tool is to show you how easy it is to keep on adding different tools to the set of existing tools which we have. So these are the two tools. And then what you can do is that you can bind the tools to your LLM. This means that now we have an LLM augmented with the tools. Um, and here you see there are multiple things which you can specify over here. This LLM.bind tools, it's a great function because you can mention if you want the tool calls to be done in parallel or not. I remember someone was asking in the chat one day that do we need to use these tools sequentially or can we use it in parallel also? So you can set this to true if you want to make the tool calls in parallel. And if you want to force the tool usage, you can even set that to true, which I have not done because I don't want to force any tool. I want to, I want the assistant to decide whether it needs the tools or not. And then as all of you mentioned, we are going to define the state. The state is just going to contain the input file. And then we are going to define the assistant. So when you just see this code for the first time, you might think, why is this assistant defined? There is a very good reason for why this assistant is defined, which I already explained to you over here. So the way the assistant node is now defined is that the assistant node is has access to all the tools. The assistant node has access to the extract text tools, and it has access to the divide tool. And here we have mentioned you are a helpful agent that can analyze some images and run computations with the provided tools. That's it. So this is how we have defined the assistant agent. It's as simple as the fact that the assistant agent has access to tools. That's it. So if you see over here, here I've explained in English language why we need the assistant agent. The assistant node is just our model with tools. We will add a tools condition edge. So we connect the tools back to the assistant, forming a loop. This step is the most important step to really understand how tools work with Langgraph. So after the assistant node execute, tool condition checks if the model's output is a tool call. If it is a tool call, the flow is directed to the tools node. The tools node then connects back to the assistant. And this loop continues as long as the model decides to call tools. If the model response is not a tool call, the flow is directed to end, terminating the process. So as we have explained over here, the assistant node will essentially make tool calls till the point it realizes I don't need to make tool calls anymore, and then we end it. And the assembly of this graph is very interesting. So if you print this out, you'll see the way we have assembled. I don't think I ran this. If you print this out, you'll see the way we have assembled this graph. See, it's as simple as this. You start, then you have an assistant. So you have an edge between the start and the assistant. Then you have an edge between assistant and the tools. So these are nodes actually. I'm just adding nodes for now. The assistant node and the tools node. Here is where we are creating the edges. We create an edge between start and assistant. Then we add a conditional edge. We have a conditional edge between assistant and the tools condition. So if the latest message from assistant is a tool call, tools condition routes to tools. If the latest message from assistant is not a tool call, tools condition routes to end. So remember, this tools condition is a function defined in Langgraph itself. We don't need to define it otherwise. This I have not defined anywhere in the code. This is given by Langgraph itself, which automatically checks whether tools are called or not. So if tools are called, basically the tools condition is positive, and then you keep on using the tools. If tools are not called, the tool condition is negative, and then you don't use the tools. So this is how we have assembled our graph, and you can check this graph now versus what we had assembled in the first code. Um, in the first code, the graph we had assembled looks something like this, right? And although this looks more complex, I would argue that this is equally complex. The reason is because the tools are now being used in a loop. So it's a very powerful thought action observation framework which we have. And now you can just do graph.invoke like we did previously. We first compile the graph. So the same steps are now followed. You compile the graph and then you invoke the graph. So we compile the graph over here, which is this. And if I ask for some simple thing like divide 6790 by 5, here of course it will only use the division tool, right? So if you see the tool calls which are made is only the division tool right now. But now let me actually check whether this agent is working or not. So I'm going to give this image. This image is what I've attached in the Zoom call, and it essentially contains a eating regimen. So if I type here, according to the note provided in the images, what's the list of items which I should buy for the dinner menu? And here I actually give the input file as the image. So that's now the state of my graph. And remember here I have connected it with Langfuse. If you don't connect it with Langfuse, you don't need this callback function. So you can run this right now. And this will use the second tool which we have, which is essentially the multimodal language model. This does take some time to run because we are actually extracting the text from the image. But at the same time, if any one of you is connected to Langfuse, you can keep monitoring your response over there. And here, if you print out the messages now, here you can see that. See here, the tool call is the extract text, which is that particular tool which is being used, and we see the tool message, which is the training schedule. Then the diet also is given over here, which means that we are able to correctly extract what is mentioned in the image: breakfast, lunch, etc. And now we can also actually go to Langfuse and see the traces again. So here I am going to Langfuse, as you can see, and I will refresh this. And I'm seeing the traces here. So see, this was the first thing: divide 7690 by 5. Uh, that's just a simple division which was used. But now the second is this, where we had um, the we were trying to understand what is present in the input image. There is a question in the chat about the tools condition, right? Can you explain how the tools condition is updated? Yeah, so let me explain that. That is probably one of the most important points in the lecture. So this tools condition over here actually makes all the difference, because so if you scroll up here and see, at one point there will be a tools condition. Yeah, this tools condition is the most important, because the assistant actually decides whether a tool call is needed. So let's say if the assistant state is that I need a tool call, then the tools condition would be converted to true, and automatically will route to that particular tool. So you can think of the tools condition as a gatekeeper to use the tools, and who decides whether the gate opens or not, that's decided by the assistant. The assistant can essentially take a call uh, related to whether you want to open the gate or whether you don't want to open the gate. And the way that is done, the gatekeeping is here. If you see builder.add nodes, here is also, as someone has pointed out in the chat correctly, you have tools, comma, tool node, and then tools. So that is important. Okay, so this is related to how the tools condition is updated. Now what I want to do is that I want to make a slightly more complex request over here, which is, according to the note provided, what's the list of items I should buy for dinner? Count the number of items and then divide them by 50. Give me the resulting answer. Don't stop till you have integer answer. So here I have given this statement deliberately so that we can use multiple tool calls. I don't know whether the agent will use multiple tool calls or not, but I've deliberately given an input statement which is slightly more complex. So earlier we just had analysis of the input images, right? But here I have asked count the number of items and divide them by 50. Give me resulting answer. Don't stop until you have the integer answer. And here I'm hoping that the agent will make multiple tool calls. And instead of seeing it here, now what I want to do is I want to see this in my Langfuse. So I'm going to Langfuse again, and I want to see this. Yeah, so this is a more complicated question, right? And here, did you see this part? Did you see these multiple loops over here? There are two loops, right? As you see, there is one loop and then there is a second loop. This was not present in the previous Langfuse. In the previous example, there was only one tool call. But now there are two tool calls which you see here. And as the question gets more complex, it will be more and more and more. This is a very beautiful visualization to see. And we can clearly see the thought action observation framework in action over here. Because in the previous case, if you see, there was only one tool call, right? There is no loop over here, but here is where we have multiple tool calls. And I believe that there were multiple tool calls because see, this is the tools condition is also tracked over here. Tools condition. And as long as the tools condition returns some tool, we will be calling tool. So there are two tools here. If you see, extract text is one tool, and there is also the divide tool. We have given two tools, extract text and divide, and both of them are utilized over here. That's the reason why we see here two loops, because the agent figures out that I should not exit this loop until both my tool calls are covered. How many of you are able to see this on Lang Fuse? This is a very important visualization, because if you see this, you will never forget it. Here we see no such thing, right? That's another advantage of observability frameworks. To all of those who have seen it, it's great. To all of those who are not able to see it currently, please try to make Langfuse work. It might be an API key issue if it's not working for you at the time. Okay, and the last thing which I've written is that what's the list of items I should buy for the dinner menu, then send an email to the recipient email with the list of items. So this I've just created randomly. And this is actually a good segue for the part two of this Google Colab notebook. So I won't have time to go completely in part two, but what I will be doing is that I'll be sharing this part two notebook with all of you. So what I did in part two is, oh, I need to sign in first probably. In part two, I have actually sent emails. So I'll tell you what I did in part number two. Again, I'm making the copy of this notebook so that I don't expose the API key. Okay, now the copy is made, so I can share it with. Yeah, I've shared the part two notebook with all of you now. Okay, so now let me share my screen once more. So what I figured out in part one is that, okay, this is fine, but when I added this last request, my last request was send an email to the recipient with the list of items. So I thought, what if we can actually send an email? So I wanted to get an actual email. So let me show you what the output of part two is. If you run part two, and I'll tell you how to run part two, you will actually get an email in your inbox. So yeah, if you run part two, you'll get an email like this. So this is an email which I actually got in my inbox, which is based on the part two code which has run. And that's pretty interesting, right? So I've made some changes in part number two essentially, which makes it a bit different than part number one. I hope all of you can see the screen now, which is part number two. So the thing is that, let's say, let me first ask you this question. If you get this recipe, which we have obtained in part one, and if you want to email it to yourself, what will you change in the code? So this recipe which you have obtained now, if you want to email it to yourself, tool, right? So all of us agree that we need an email tool. So that is exactly what I've integrated. And the tool which I've used, which helps me to send an email, is this tool called SendGrid. So this I won't fully show you right now, but it's actually very simple. You just go to sendgrid.com. You create an account over here. And then when you create an account, what you'll see is that on the left-hand side, you'll see settings and you'll see API keys over here. So you create an API key. And this is the API key which I have mentioned over here. This is my SendGrid API key. But you don't have to stop here. What you have to do is that you have to go to sender authentication and you have to essentially add the email from which you want to send that email to. And you can also add receiver authentication over here. So the email where you want to get that email, that also needs to be verified. And once you do both of these steps, then you will need to add, that's it. Then you need to add the tool. Now let me ask you, where will you add this tool? Actually, over here. Yeah, where will you add this tool? Let's say you make that email tool. Yeah, correct. So as many of you are saying, there are two steps which are very important in the code which I just showed you. Not one step, but two step. The first step is this LLM tool binding. So if you see over here, this is the most important or one of the important steps in the code where you can bind a tool to an LLM. And then you can add this tool to the assistant node essentially. That's exactly what we are going to do. So if you see in the part 2 code, what I've done is that here is where I define the send HTML email and I mention the sender as this. This I have authorized. Actually, you don't need to authorize the receiver. You just need to authorize the sender, I think. So here my sender is verified. And this is the receiver which I've added. And the subject is dinner shopping list. So this is the second tool which I've added now. The only thing which you need to change is that this LLM with tools. So the tools which you bind to the LLM now, it has these tools which are, this has the divide, this has extract, and it has send HTML email. This has three functions, right? Earlier we just had two functions. So make sure that you have three over here. So whenever you want to add more functions, you just do comma and keep adding more functions over here. This is one place, and then that's it, because now the assistant, in the assistant, you have to mention that you also have access to this tool. So earlier we only had this much, right? Then you have to mention that the assistant only has also has access to one more tool, which is send HTML email. And then finally you just build this, and the beauty of Langgraph is that this graph actually is the exact same, right? Nothing changes. It just that in the tools we have added one more tool now, which was not added previously. And then when you actually send an email, you will actually see the thing that the email has been sent. And that's really very great to see. I don't know if I have the tracing for it here right now. I think I had it. um, Probably. Yeah, I had seen the trace for this, and it actually has multiple loops because you also send an email, right? So it looks great on Langfuse. This is a simple code to run. All of you just need access to uh, these keys. You need access to SendGrid API key, OpenAI API key, Langfuse secret key, and Langfuse public key. That's all. Everything else is exactly the same as what we have seen in the previous part 1 code. So essentially what we covered in today's lecture is starting with a simple concept of nodes, edges, and states. We can slowly build up the complexity to make very difficult projects. So first we build this email sorter and sender. Second, we built a vision assistant agent. The part one is just a simple vision assistant agent, and part two is advanced vision assistant with email sending. Now, what I've done is that since Langgraph lecture is over, there are some advanced projects which I will add for pro plan registered people. There are three advanced projects. In fact, one is the resume checker agent, one is the end-to-end flight travel planning agent. This I've constructed through Langgraph, and the third is agentic RAG event management. These projects I have finalized, and I'm making a private GitHub repository which will be accessible to people on the pro plan. Now, the thing is, these projects, you will now find it much more comfortable to understand and go through. These are industrial scale projects, and the code will look pretty long when you see it. But you will not be scared of it now, because ultimately it all boils down to the same thing. Here, there will be more tools. Here, there will be more loops and more conditional edges. But the core of it remains exactly the same. The core of it does not change. There will be state, there will be nodes, there will be edges, and there will be loops. There will be loops like this. This is an important concept to understand, because unless you understand this, you won't understand the link between the thought action observation loop and how agents are used in LangGraph. So this I'll be sharing after the bootcamp is over. with all the people in the pro plan. So you can execute these projects and you can even add it to the resume if you want. So let me do a quick revision of what all we have learned today, because again, today's lecture was quite long. First, when do you use Langgraph and when do you use LangChain? That's extremely important. And you may forget the technical details after 3 months or 4 months, but you will not forget examples. So if you are ever asked this question in an interview or anywhere, just think of the example which we have seen. What's the issue with the linear framework? It's difficult to handle conditional statements. That's why for non-linear frameworks, it's better to have a graph-based structure where it's easy to add conditional statements, and state persistence is also better in graph-based frameworks. Then Langgraph is built on three main pillars: nodes, edges, and state. So if you forget these three, just remember NES, nodes. So you can think of it as north, east, south, NES. So nodes, edges, and state. And nodes, so start thinking from the state. So in our email sending project, the state was the email. Edges were the functions such as reading email, drafting email, sending email. No, nodes were the function. Sorry, state was the email body, whether it's spam or not, etc. Nodes were the functions such as sending email, drafting email, etc. Edges are just the connections between the nodes. So edges connect different nodes together. Then what we can do is that after you understand the nodes edges state framework, then the door is open for building any sort of a simple agent, but still you don't know how to add tools to it and how to enter the thought action observation framework. One way around this is to just define assistants and make the assistants go into loops. If you want multiple agents, you can define multiple assistants working together. Whereas, so if one assistant has 8 tools, that's not very good utilization of this assistant, right? Because as we have seen before, it's better to split tool usage among different agents. So then you can have different assistant nodes connected in whatever your decision workflow is. That's also possible. And then finally, we saw that it's actually quite easy to keep on adding tools. The way to do that is that you just change the tools which are bound to the LLM. Here is where you change the tools which are bound to the LLM. You can keep on adding as many tools as you want. And then one more place where you have to change it actually is when you define the assistant. This you can think of like a manager agent. So you have to tell it which tools does it have access to. And then finally, for all the Langgraph based agents, you just have to do graph.invoke. So first you have to do builder.compile. So you have to compile it and then you have to do graph.invoke. That's it. And then you go through the entire workflow. So this is a bit similar to agent.run, which we have seen in small agents, which we have seen in Llama Index now also. So thanks everyone. This brings us to the end of today's lecture. The next lecture which we'll be having will be our 9th lecture, that will be on Creo AI. Lecture number 9 again will be held tomorrow, and that will be held at 2 p.m. IST. And after that, we have one last lecture which is remaining. In that lecture, we'll cover NA10, we'll cover MCP, and we'll also build several workflows using NA10, etc. So this last lecture will be covered by Dr. Sridath, which I think many of you are aware of. He also completed his PhD from MIT. I'll introduce him before he joins the last lecture so that he can take so we can take this forward. Yeah, this Langgraph is extremely powerful. So the framework which I've introduced to you today can serve you for any type of project which you want to build in enterprises also. This is an actually enterprise level framework. This is not for building toy projects. You can build toy projects in small agents, but for industry level projects, Langgraph is the best framework to use. Tomorrow, we are also going to see another industrial based multi agent framework, which is Creo AI, which is also incredible. And there, the amount of coding involved will be way less. So, Langgraph is a pure code based agent, right? But pure code based agentic framework. Creo AI is much simpler. So, don't worry, tomorrow's lecture is not going to be as complex as today's one. But today, it had to be a bit complex because otherwise, uh, it's difficult to understand. And once you understand these things, it's simple to build the Langgraph. So tomorrow we'll build multiple agents through Creo AI. I look forward to seeing you in tomorrow's lecture. Thank you, everyone. See you. Bye.